Welcome back for another video lesson. Today we're going to be discussing the law of sines. Let's go ahead and get started. The law of sine applies to an oblique triangle, and an oblique triangle is one that has no right angle, which means that we can't use regular sine, cosine, or tangent. Instead, we use the law of sines. And there are two main types of triangles you'll see. There's an acute triangle, which has all angles less than 90, or an obtuse triangle, which has one angle greater than 90. But again, the important thing is all of our triangles today have no right angles, which means we cannot use regular sine, cosine, or tangent. Let's go ahead and look at when the law of sines can be used. The law of sines can be applied in three different scenarios. Either you have two angles in a side with angle, angle, side, or angle, side, angle, or you have two sides and an angle, and that would be side, side, angle. The important thing here though is that you always have a side and a corresponding angle. So we could have angle C and side C, that would be one set. Or maybe we have angle B and side B. The important thing here is that you always have a side and its corresponding angle, and that indicates to you that you can use law of sines. Let's go ahead and look at the formula for law of sines. Alright, so here we have our equation. It is A over sine of A equals B over sine of B equals C over sine of C. One thing that is important to note here is our lowercase letters are always going to be sides, and our capital letters are always going to be angles. So in this case, all of your sides are on the top, and all of your angles are on the bottom. Because of this, we call this the standard form, and we're using this one to help us solve for the missing side of a triangle. To do that, we need to make sure that we again have a pair, either an angle and its corresponding side. So let's say that we had side B and angle B, and we had angle C as well. We could then use that information to help us solve for side C. In this case, we didn't need information from A. Or maybe we have side A and angle A, and we have angle B. I can then use the information to help me solve for side B. So to kind of generalize, to use this formula, you need to have three of your four things for two ratios. So we need to have two angles and one side. And again, you always need to have a corresponding side and angle to use the formula. Let's go ahead and apply it. Alright, so here we have a standard triangle, and all we're going to do here is try and set up the ratio. So the first thing that's very important to note is that we have a side and a corresponding angle. We have 12 meters and 43 degrees. So I'm going to start with setting up my ratio. I know that my side needs to go on top, so I have 12 over the sine of 43. The next thing I want to do is figure out what other information do I know. So I know that I have an angle, and I can use that to help me find the corresponding side. In this case, it would be side B. So the rest of my ratio would then be B over sine of 83. And now that I have my ratio, I could then solve this by multiplying both sides by the sine of 83 to get B. Again, the important thing to note here is that we had a side and corresponding angle that kind of indicated to us to use the law of sines. Here's an example of a triangle that you might think you could solve using law of sines, but we can't. So we're going to set up some ratios and indicate why we cannot do that. We do have a corresponding side and angle, so I can start with that. 12 over the sine of 83. But in order to fill out my ratio, I need to know another angle. And if you look at a triangle, I don't know what angle A is, and I don't know what angle C is. So no matter how I fill this out, let's say we have angle C and side C, my ratio would be C over sine of C, which gives me two different variables, both the side and the angle. Let's say that we wanted to solve for side A instead. We'd have a similar problem, because I don't know what side A is, and I also don't know what sine of A is. So in this case, if I wanted to be able to try and finish solving this, I would have to know either angle A or angle C to help me solve for either side A or side C. Alright, it's your turn. I want you to try and set up a ratio using law of sines to help you solve for one of the missing sides, either side B or side C. Go ahead and answer the question now. So sometimes we want to solve for an angle instead of a side. In that case, we have the alternate form. And the alternate form is just the reciprocal of the standard form. But the nice part about it is we have the angle starting on top. Again, if we wanted to solve using this, we'd have to have two of our three ratios. So maybe we have sine of angle A over A and sine of angle B over side B. It's important to note though that this can be solved if we have side-side angle. So we have two sides and an angle. The other form, the standard form, would be used if you have two angles on the side or angle side angle. But again, we're going to focus on side side angle for this form. Alright, the first thing we want to do is check to make sure that we have a corresponding side and angle, and we do. We have side of 12 meters and angle 43 degrees. The next thing to look at is we have a side. So since I have two sides and one angle, I can use the alternate form of law of sines to help me solve for another angle. In this case, the other angle is going to be b, since that corresponds to 20 meters. So we can start by setting up our ratio. We would have sine of 43 degrees over 12, and that's going to equal the sine of b over 20. Again, I'm using the alternate form here because I'm trying to solve for an angle, in this case angle b, and so I know to set my angle or my ratio up in this way. To finish solving this, which we'll do in a little bit, we would have to use some inverse trig, just going back to the principle that to solve for an angle you always have to use the inverse, but for right now we just want to make sure we can set it up. Alright, so looking at this triangle, something is missing. I want you to try and figure out what information you would need to help you solve for angle C. Alright, your turn again. Looking at this triangle, you have enough information to set up a ratio to help you solve for an angle. I want you to figure out what the ratio would be and what angle you would be solving for. Alright, so now it's time for the fun stuff. We are going to actually be solving for the missing information of the triangle. The first thing I want to point out is that all of my triangles are not drawn to scale. In this case, you can see that I have an acute triangle, but we obviously have an obtuse angle. So again, my triangles are not drawn to scale. Alright, let's go ahead and label our things though. So I know that angle C is 102.3 degrees, so it would be this angle here. I know that angle B is 28.7, so this is 28.7. And I know that side B is 27.4 feet, so 27.4. Alright, noting that we have a corresponding set, we have a side and an angle that correspond. I now want to figure out what am I missing. I have two angles and one side. Since I have two angles and one side, I can use my standard form to help me solve for another side, which would be side C. So I'm going to go ahead and set up a ratio to help me solve for side C. Now we're going to start with what we know. So I have side B, which is 27.4, divided by the sine of 28.7, and that's going to equal side C over the sine of 102.3. Alright, we have one step to perform to get C by itself, and that is multiply both sides by the sine of 102.3. So 27.4 times the sine of 102.3 divided by the sine of 28.7 is going to give us our answer. Alright, so that gives us a total of 55.75. The nice thing about this triangle is since I have two of my three angles, I could very quickly subtract each one of those from 180 to help me figure out what my missing angle is. And once I knew that missing angle, I could then use that angle to help me solve for the corresponding side A. We're going to go ahead and move on to another example now. Alright, looking at our next triangle, we're going to label what we have. We know that angle A is 36, we know that side A is 8, and we know that side B is 5. Now we know also that we have two sides and one angle, so I then set up my ratio to help me solve for another missing angle. In this case, we're going to solve for angle B to help us complete our set of side B and angle B. Starting off the ratios, I know I want to solve for an angle, so I'm going to have the alternate form, which means that I have the sine of 36 divided by 8 equals the sine of B divided by 5. We have a few more steps when using the alternate form. We're going to start off by multiplying by 5. So we have 5 times the sine of 36 divided by 8 is equal to the sine of B. And then since we're solving for an angle, our last step is always to take the inverse to make sure that we can get our angle by itself. So we would have the sine inverse of 5 times the sine of 36 divided by 8, and that's going to equal angle B. Alright, if we calculate that, then we get our angle, which is 21.55 degrees. again, the nice part about this is now that I know my two angles, A and B, I could subtract each one of those from 180 to get angle C, and I could then set up another ratio to help me solve for my missing side C if I needed to, using the standard form. Alright, we have one last example. I'm going to get you started and then let you finish this on your own. So the weird part about this one is we have degrees and minutes. Looking at my first angle, it's 88 degrees and 35 minutes. To convert minutes into a decimal, you're going to divide by 60, because there's 60 minutes in a degree basically. So you have 88 and 35 divided by 60 to complete our angle, which is 88.58 degrees. We do the same thing for our next angle, so I have 22 and 45 over 60, which is 22.75 degrees. So now that we have these angles, I want you to go ahead and label your triangle and solve for the first piece of missing information that you can.